Okay, so we're going to start out talking about what an increasing function is and what a decreasing function is. And we'll talk about them in sort of the general everyday sort of sense. An increasing function is one that if you pictured a little man walking from left to right, walking along the graph, he would be climbing uphill if you went from left to right. So it's increasing if the graph moves up as x moves to the right, as our x values go from left to right, and decreasing if he's walking downhill from left to right. Okay, so pretty straightforward. And there are, the formal definitions of increasing and decreasing, and you can look those up in the textbook if you would like. But I just wanted to, so we got a feel for what those are. Next, we need to talk about what a critical number is, and because we're going to use those in doing our tests for increasing and decreasing, and then also when we look for relative extrema. So a critical number is a point on the graph. So f of x has to be defined at c. There cannot be a hole or an asymptote at the value c. Then c is a critical number of the function if one of two conditions is satisfied. If the derivative there is 0, so if it has a horizontal tangent there, or f prime is undefined at c, so it has one of those pointy portions at c. So if you think of the absolute value function, what its graph looks like, which is basically a v, the derivative is undefined at the vertex of that v. And so that would be a critical number. So it says, note, for c to be a critical number, it must be in the domain of f. That's what I meant about there cannot be a hole, there cannot be an asymptote at that value of c. Okay? So if the derivative is 0 or the derivative is undefined at that point, then we have what's called a critical number or a critical value, critical point. All of those are used when you take a look at math textbooks. Okay? So in order for us to test whether or not a function is increasing or decreasing, this is the test that we'll use. And if we think about what it looks like, or what a function looks like when it's increasing and decreasing, actually let's go ahead and draw a graph of that. Let me go to the e-board and make some comments here. I'm going to do some drawing. Okay, here's a function that has some increasing portions and some decreasing portions. And so let's talk about what we've got going here. On the increasing portions, what can we say about the slopes of all the tangent lines? Okay. What can we say about the slopes of the tangent lines for these parts where the function is increasing? Well, we notice that the slopes of the tangent lines are positive for the portions where the function is increasing. So that means if the slopes of the tangent lines are positive, that means the derivative is positive, greater than 0, if we have increasing. Now, if we take a look, on the other hand, where we have decreasing portions of this function, and in particular here, okay, what can we say about the slopes of those tangent lines? Well, where it's decreasing, the slopes of tangent lines are negative. Or in other words, the derivative for those values are negative. Okay, so that's our test essentially. What about the places where we have neither? Where we're not increasing or decreasing. So for example, at the top of the hill or the bottom of the valley. Well, that's going to be where it's neither increasing or decreasing. Okay? So that's where the slope would be 0, okay? F prime would be 0. So that makes sense.